In this session, we're going to take a look at GeoGebra's global menus at the top of the screen. We'll be looking at the options. However, Drawing Pad, near the end of the list, is a fairly long list in itself, so we will not cover that one in this tutorial. We'll cover point capturing down through language, and you would find Drawing Pad as a separate tutorial. The first option under the Options pull-down menu is point capturing. To make these a little bit more understandable, we're going to put a grid into view. Turn on a grid, and we'll make our scale a little bit larger. Okay, now let's go back to the Options menu and take a look at point capturing. Automatic will let GeoGebra try to do its own best judgment. What's it mean to have the point capturing on? Well, let's watch what happens. We'll actually start with on grid. On grid simply means if we want to place a point, wherever we click, GeoGebra will put it to the closest point that's actually on a grid. As you can see, this is not very accurate compared to where we actually have the cursor. But that's what the grid does and can make it very useful for student activities, particularly in lower grade levels. Let's go back and let's see what happens when we turn it to off. In the off mode, there is no selection going on at all. It just goes exactly where you put it. So we have our points going wherever we choose to have them appear. And the other option, on by itself. Now what will happen here is if we click quite far away from any intersection on the grid, it'll simply put it there. If we move our cursor so that it's pretty close to an intersection, a little bit closer, now all of a sudden it jumps. The closer we get, that one was okay. We'll go over here, and if we get pretty much a guideline is if it's a little bit less than the crosshair itself, it goes to the point of intersection. So it's sort of like a hybrid between being off and being on. We'll go back now to the angle unit. Let's clear our screen. And let's go back to the standard settings. Okay, we're back. We have no grid, and we're back to the normal magnification level as it appears in default. The angle unit is a very simple adjustment or simple menu item. All it does is determine what we're going to measure in. The standard default is degrees. So let's do a simple little activity. We'll just create an angle. There we have an angle, and its measurement is 29 degrees. Remember, we can pull that angle measure out, and we'll do that. 29 degrees, and it will adjust as we've seen before. But now let's go back to the options menu, and let's change the angle unit to radians. We are now measuring in radians. We're also measuring, if we move this, it takes a while to make any difference. And the reason is that we have another option that we're going to change momentarily, decimal places. We're going to bring that down to at least 2 or 3. Now, that now gives us a much more meaningful number. It was okay when we were working with very simple values, but when we get into more complex operations, we certainly want to have the ability to have numerous decimal places for whatever is needed. Once again, now when we move, we see that we're measuring in radians, but with a lot of precision now. Next item we'll take a look at under options is our decimal places, which we just visited. This doesn't affect the coordinates, it affects the calculated values, as you just saw in decimal places. If I go to 5 decimal places, I now see that my angle is being measured to 5 decimal places, but in radians. And this would be true of if we were doing square roots, if we were doing powers, if we're doing numerous other calculation values. Continuity can be either on or off. The standard setting is off. This is a fairly complicated idea and fortunately not needed very much in high school level work, but the best way to take a look at it is to see an example. So we'll call up an example, a continuity demonstration. Here we have two rays forming an angle, and the red line is bisecting that angle. Now we're going to move point A to change the angle. Since the bisector is cutting the angle in half, if we go 360 degrees with point A around the vertex, then D is going to move half that amount. But watch what happens. As we get to as we go by the 180 degree mark, all of a sudden point D has moved to another location. That could lead to some misconstrued information being derived from the diagrams. So an option there is we'll turn the continuity on. Now we'll move point A again exactly the same way, and when we get around to 180 degrees, point D does not move. Instead, point A has to go around point B 2 rotations in order to bring point D back to where it had been in the first place, which is a truer representation of the mathematics, but it's also a setting that's not used very often, so the default is left at being off, and I'll put that back to off. The next item we have in our options menu is point style, and that's quite self-explanatory. The standard is a simple dot, but we could use an X, and to demonstrate that we'll just put in a couple points. Now instead of getting a dot, we just get an X, not a huge obstacle or huge helpful thing either, but depending on what type of mathematical work you're doing, you might find the cross or the X a more useful notation, or perhaps just to distinguish between one point and another. However, you'll notice that it did change all the points here into X's instead of the dots. Similarly, if we wanted to use the open circle, now they've all changed to open circles, and again, that's just a variation that may be useful depending on the type of problem that you're doing. The right angle style is going to affect right angles only. This will occur if we're creating an angle with a specific measure, and we'll see that with this example. Right now I've chosen the square symbol, which is probably the one most commonly used, and let's see how it works. We'll go to our angles. We'll choose an angle with a given size, pick 2 points, and now let's set that to, instead of 45 degrees, we'll choose 90 degrees here. And when we hit apply, we now have an angle, and it is going to be, it's set at 90 degrees, and that becomes stationary. If we try to move point G, we notice that point G prime moves along with it because it is part of the 90 degree definition. If we move point H, we also see that relationship, but all that happened in this case is that our label turns into a square, and that marks the corner. We could, of course, add lines, and we'd still be preserving the square notation. Again, you have the option of having no symbol there at all, or having it marked with an arc, just as we have over here with this 60.61 degree angle. Then next item we have is coordinates. That one's quite self-explanatory. In our country, in high school classes, the standard would be the first choice. We would rarely, if ever, really need to look at the other two, but they're there for users, because remember that GeoGebra is a program used all around the world. Labeling gives us some options for how we're going to go about labeling our objects, and that includes points, lines, equations of things like parabolas, drawn objects such as polygons. The standard is to let the computer put its own default sets in. We can choose all new objects, and that will dictate that everything gets labeled. Let's try that. Now let's draw something simple like a polygon. We're drawing just a simple triangle here. Let's make it a little bit larger so that we can actually see that. Okay, we see that the computer has applied I, J, and K as labels for the sides. It has applied vertices identifications I, J, and K, and it has even named the polygon itself as Poly 1. Going back to the options menu, we could also choose no new objects. Let's choose that and demonstrate what it would do. Again, we'll use the triangle. We'll draw a different triangle. And notice that this time no labels have been created at all. Point F had been there right along. And finally, we have new points only, and what that will do is label only points. And once more we'll draw a triangle. Points O, P, Q, and back to O again, but this time we don't have any labeling applied to the sides, nor do we have it is polygon 3, however it is not labeled on the diagram. As soon as I move away, that labeling is just temporary. Font size affects all the fonts available on the menu. So let's try that and see what it does. We have 12 point right now. Let's move that up to, let's say, 24 point. And what we see is all of our labels being impacted. Obviously this is making quite a mess right now. That's not awfully useful considering that we had created a diagram that was using smaller labels to begin with. However, if you know you're going to be making something such as a poster, or if you're going to be projecting using a digital projector, ceiling mounted or stand mounted, this can be a very useful tool to make your displays on a screen readable from just about every point in the classroom. Let's again change that back to our 12 point. And the last one we'll look at this point is language. Language can be tricky because if a student does this, they're apt to forget how to change it back. You can always quit out and just restart GeoGebra, but what it gives us is the ability to look at GeoGebra in a language other than US English, and let's try that just for curiosity's sake. So we'll go to a traditional Chinese. Now, we see our labeling is still intact because the Chinese use standard labeling, but our directions up here are now written in Chinese and may be meaningless. So we see our menus down below. The commands are still written in English. The input button is written in Chinese. Even our global menu is appearing in Chinese, and again, this is where students could get confused, but if you simply scroll through here and remember that that menu item is accompanied with a world icon, it's pretty simple to go back, find our English again, and convert it back. Again, remember that GeoGebra is used around the world, and it is a very universally accepted program. There is one more item under options, and that's the drawing pad. That has so many submenus within it, that will be treated in a separate tutorial video.